Hey there, stats enthusiasts. Welcome back to our AP Statistics series. We are currently in Unit 5, which is all about sampling distributions. I'm Goldie, and today we're going to be focusing on creating a sampling distribution for a difference in sample proportions. We'll see that the information we talk about today is very helpful in comparative studies, which serves as the basis for many of the studies that you hear about every day. We will also be revisiting information on combining random variables, and that really gets to have its full circle moment. So sit back and get ready to take notes on these sampling distributions for a difference in sample proportions. As we go into Notes 3, it's important to keep in mind where we've come from. So in the video right before this, we discussed the sampling distribution of a sample proportion. And now in Notes 3, we're going to be discussing the sampling distribution of a difference in sample proportions. And the first question I always like answering is, why do we have this? So we have the first sample proportion sampling distribution. Why are we moving into a difference in sample proportions? So it actually is very useful in a lot of studies that we do where we have comparisons. And specifically, we're going to look a lot more at these studies in Unit 6, but what we're doing now kind of sets us up for success in Unit 6. So these sampling distributions we're going to create in today's video are used to answer the question of which is better, right? So for example, if I have two of the popular drugs on the market to help lower bad cholesterol, I have Lipitor and Pravachol. Which one helps lower bad cholesterol more, right? If we were comparing them, you want the best one. You want the one that helps lower it more. So which one does that? Okay. So in this situation, if we wanted to compare them, we're not trying to apply anything to a larger population. We're trying to discern between two explanatory variables, and we use an experiment to help us do that. So if we set up an experiment, let's say researchers used 4,000 people with heart disease as subjects in a completely randomized experiment. So they're going to take 4,000 subjects, and they're going to randomly assign them to one of two treatment groups, either Lipitor or Pravachol. Okay. And then at the end of the study, the researchers compared the proportion of subjects in each group who had died, had a heart attack, or suffered other serious consequences within 2 years, right? So we're looking at the proportion of serious consequences within each group. So in this experiment, Pravachol 0.263 suffered a serious consequence, and for Lipitor 0.224 suffered a serious consequence. So if you look between them, we obviously want a lower proportion suffering serious consequence. So if you look between them, Lipitor has a lower proportion than Pravachol. So does this mean that Lipitor is better at lowering bad cholesterol, right? Because in this completely randomized experiment, it was. Okay. So what we have to ask ourselves is something that came up in the video before this. And is this difference a result of Lipitor being better, or is it merely due to chance involvement in the random assignment of treatments? And that chance involvement in the random assignment of treatments, that goes back to sampling variability, right? We have a natural sampling variability whenever we use a random sample, and same thing goes with random assignment, right? While we try to control things in an experiment, we can't control everything, especially when it comes to that natural variability that occurs between two groups. So making a sampling distribution for this difference in sample proportion will help us answer this question, okay? So let's recall what we talked about in last video. Let's summarize this. What is the sampling distribution of a sample proportion? What's the shape, center, and spread of it? Well, the shape's going to be approximately normal as long as our large counts condition is satisfied, all right? And then we can say our shape is approximately normal. The center of our sampling distribution was equal to our population parameter, as long as we randomly selected when we're sampling, or if we were to randomly assign in an experiment. Now that tends to happen more in what we're about to do today when we have two sample proportions. We tend to get that random assignment from experiments. And then spread. We had a formula for the spread of our sampling distribution using our population parameter as well as our sample size n. And we could do this as long as the 10% condition was satisfied. Okay? And this is important to note because we're getting into experiments today. This is only when sampling. We only have to check the 10% condition when sampling because it's a condition that involves being able to sample without replacement from our population at large. Okay? So this is our sampling distribution for our sample proportion. Now, what I also want us to recall is combining random variables. Now, we already went through a big portion of this in the first video of this series, so I just want to quick recap what that was. When we combine random variables, the shape of combining two or more normal distributions will also result in a normal distribution. The center, if you're taking a difference, the center is going to be the difference of the two parameters. Okay? And then the spread, if we're taking a difference, the spread, the standard deviation, we have to add the variances and take the square root of that value. Okay? So recall those three combining random variables for shape, center, and spread. Because that's what we're going to do when we create the sampling distribution of p hat sub 1 minus p hat sub 2. We're going to take what we know about the sampling distribution of a sample proportion and put it together with combining random variables. Now, when I say p hat sub 1, that's the sample proportion from the first group. Think of like the Lipitor group. Whereas p hat sub 2 is the sample proportion from the second group. Okay? Now, usually we use subscripts of 1 and 2, but subscripts can be anything. They can be numbers, they can be letters. They're just used to separate between the two groups. Okay? So if we have two groups and we have a sample proportion from each group and we combine them by subtracting and finding the difference, what's the shape going to be? Approximately normal. Okay, that's just going to be the shape we want basically for the rest of our inference unit is going to be approximately normal. Of course, there's conditions that go along with it. And that means that both distributions, both of your population distributions must satisfy the large counts condition. So we would use n sub 1 and p sub 1 and n sub 2 and p sub 2 and make sure there's basically 4 of them right there, right? There's this one, this one, this one, and this one. So you have to plug in your values, basically check all of those, and as long as they're satisfied, the combined distribution will be approximately normal. Now center. Okay, so center of this distribution. Well, if I have the first sampling distribution. Now this is quite the notation here because I have mu sub p hat sub 1. Okay, so I have like a super subscript. Okay, but it's the center of our sampling distribution of our sample proportion for the first group. We know that that's equal to the first population parameter. Same thing with the second. So when we take the difference, we're going to subtract the 2. Okay. And this is as long as both have been randomly selected from the population or involve random assignment for an experiment. Okay. So the center is the difference between the two population parameters. Okay. And now we get to the spread. Okay. So this is fun. So the spread, stick with me here. So we have our two standard deviations for our sampling distributions, okay? And note that I just put in the subscripts of 1 and 2 to denote the two groups, but this is the same formula we have been working with, okay? So what I know, when combining random variables, you always add variances. Okay. So even though I'm going to find the difference between these two distributions, I always add variances. And that's what I have on the screen is kind of like that skeleton template, right? I want to add the variances. So in parentheses, I put both of those standard deviations. All right. So I'm going to slip both of those standard deviations into parentheses. And then we're going to have just a little bit of algebra here to kind of simplify this this formula, okay, right? The little bit of algebra is the square root and the square are going to undo each other right here, okay? So what you end up getting is that big square root bar, and then underneath here you add those two, the P1 times 1 minus P1 over N1 plus P2, 1 minus P2 over N2. Okay, so merging two ideas there. That's going to be the formula now for the standard deviation of the difference in sample proportions. Now, of course, this is the formula as long as both samples satisfy the 10% condition. So we'll check both of these. Again, N1 and N sub 2, the capital letters. Usually we have words for those population descriptions, okay? And of course, that's only true too if you are sampling, okay? If you are sampling. If you are not sampling, this is the spread. Don't have to check the 10% condition, okay? Of course, we want our two groups to be independent, but in a well-designed experiment, they are going to be independent. So that's not something you have to check or worry about. Okay. So to answer the original question, now that we have a sampling distribution of a difference, is there a difference between Lipitor and Provical? Well, we actually need to know a little bit more about hypothesis testing. Not too much more, but we do have to know a little bit more from Unit 6 before we can answer this question, okay? But we're headed in the right direction there. For now, we're going to look at an example right now that involves finding probabilities of a difference between population proportions. Very similar to what we have been doing, but now we're looking at a difference between those proportions, okay? And this is going to be the final example of this video. We're only going through one example, and then we'll practice some more after that. So one example here. So what this says, a recent study examined the percentage of young adult women and men who got less than 7 hours of sleep a night. So in this study, 45% of women and 38% of men get less than 7 hours of sleep a night. What is the probability that a random sample of 50 women and 75 men will result in a difference of 15% or more between the two groups? Okay, so 15% or more between the two groups. Now, in this wording, there are actually two probabilities implied here that we are going to find, okay? Because they want to know 15% or more between the two groups. They don't say if it's going to be which direction. So if it's greater than this 0.15, or if it is if that difference is less than the negative 0.15. So basically, which direction? 15% or more. Almost like the absolute value here. This is probably what I should put. Is the absolute value greater than or equal to 0.15? So of course, with an absolute value, we have to set up two inequalities to solve that. Now, most of the time for these problems, there is only going to be one direction implied. So if the question said something like, will result in a difference of 15% more women minus men, women having more than 15% who get more than 7 hours of sleep a night, that would be implied only in one direction. But here we have two probabilities implied. Okay, so we're going to go through our 4-step process. We're going to communicate, check conditions, calculate, and then conclude. Okay, so communicate. First, we want to communicate what our two proportions are. So I'm going to use the subscripts W and M instead of 1 and 2, just to make sure I'm keeping it straight in all of my calculations. So proportion of women is going to be P sub W, and proportion of men is going to be P sub M. So we want to communicate that, and we also want to communicate our inequalities that we are finding, okay? So these are going to be the two that we are trying to find. We're going to try to find if the women minus men, if subtracting those is going to be 15% or more, or if the other way is true, if women minus men is going to be less than negative 15. So this implies that men
the proportion of men would get more than 15% of women, or more extreme, when we look at those two proportions. Okay? So that is our communicate. Okay, those are the things we want to communicate in step 1. Step 2 is going to be check conditions. So we have random, independent, normal. Random, both samples, they said it was a random sample. So that means we can find the center of our sampling distribution. So this notation, please use the correct notation here. Take a look at this. It's quite the Eiffel, because it's mu, and then all of this is in a subscript. P hat sub 1 minus P hat sub 2, that is all in a subscript there. But that says that's the center of our sampling distribution of a difference in sample proportions. So to find that center, we subtract our two population parameters, 0.45 minus 0.38. Okay, so the center is 0.07. Next, we check independent. Okay, and we have to check the 10% condition because we are randomly sampling. We have to check it for both groups. So 50 was our group for women, and 75 was our group for men. And we want to check to make sure both of those are less than 10% of the entire population that they represent. And it's a safe assumption to make, right? There's millions of young adult women and young adult men. So since this is a safe assumption, we can calculate our standard deviation. So with the formula, when you're showing your work, you don't have to necessarily show the formula, right? So I don't have to write down square root of P sub 1 times 1 minus P sub 1. You can show what is on the screen. You do have to show the values substituted into the formula, but you really don't have to show any more algebra than that, okay? So the standard deviation is going to be equal to, and I have the values plugged in here. Again, 0.45 is P sub 1, this is N1, P sub 2, and then this is N2. Okay. And if you calculate that, you get 0.09 when you go ahead and round there. Okay. The last thing we want to know is if it's normal. Okay. And if it's normal, I have the large counts condition I have to check. So first I'm going to check it for my young adult women. So I'm going to take the sample of women, multiply it by the population parameter for women. And then for men, the sample size of men multiplied by the population parameter of men. And of course, 1 minus that. And both of those, or I say both of those, but all 4 of those inequalities are true. So since all of those conditions are satisfied, we can say that the combined distribution will be approximately normal. Yay. Okay. Now let's calculate. So this is going to be step 3. This is the calculate part. So we have 2 inequalities here, okay? 2 inequalities. And I just discovered that the sampling distribution is normal with this mean and this standard deviation here. Okay. So I can figure out these probabilities. Okay. Now to figure out the probabilities, I have to convert both of these into a z-score. So let me start off with this inequality first. So this inequality, to change this into a z-score, I take this value, I subtract the mean and divide by the standard deviation. Okay. So that's what you see in this work here. 0.15 minus the mean divided by the standard deviation, and I get my z greater than or equal to 0.889. And to figure out what that probability is, I go to my calculator. On the screen is a screenshot of what I would put into my calculator. Please do not write the calculator speak down. Just go straight from this notation and you can write down the probability right next to it, okay? And that's going to be 0.187. And I'm going to repeat, and I'm going to do the same thing for my second inequality here, okay? That the difference of those would be less than or equal to negative 0.15. Again, that's saying that the difference is still greater than 15%. It's just greater than 15% when the men is larger than when the proportion of men is larger than the proportion of women, but more than 15% in that direction. So again, this is Z. I want to change this into a Z, so I'm going to take this value, subtract the mean, divide by the standard deviation, and then I get this value, Z less than or equal to negative 2.444. Put that into my calculator. These are the boundaries that I'm looking at, and I'm going to get my probability of 0.0073. Okay. Now I expected that probability to be a bit smaller because in my original difference, women was larger, the proportion of women who got less than 7 hours of sleep was larger than the proportion of men, but still something that I needed to make sure I found the probability of. Here is what that area looks like, what we just found. Okay, so I have both of my z-scores labeled there, and then the probability is represented by the shaded region by that area. Okay. As always, drawing the curve is optional on the AP exam, but I highly encourage you to do it just so you can get that visual, especially if you're a visual person. And that was the calculate part. We calculated our two probabilities. Now we need to conclude. Okay, what is our conclusion? We want to bring back the context of the problem and answer the question. So the probability that a random sample of 50 women, and 75 men will result in a difference of 15% or more, getting less than 7 hours of sleep. So there's my context between the two groups is, and then I have this probability by adding up these two values. Okay, and that is the end of that. So your conclude can only, I say it can only be, but it only has to be one sentence. And it just has to bring back the context of the problem to finish up the answer.
And that wraps up today's lesson on sampling distributions for a difference in sample proportions. We are over halfway done with our series. We only have 2 sections of notes left. The next one is going to cover sampling distributions for a sample mean. And the last one after that is going to cover sampling distributions for a difference in sample means. If you found this video helpful, don't forget to hit the like button and subscribe to my YouTube channel for more AP statistics content. Until then, I wish you endless statistical success, and I will see you in the next video.